Physics project by Anne Luke, Melanie and Ash, and Michelle Curtin.
Ohm's law forms the basis for understanding how electricity flows through circuits.
Ohm's law is voltage equals resistance measured in ohms times current measured in amps.
We will be measuring the relationship between voltage and current. By finding the correlation between these two things, we will be able to tell resistance.
Our variables in the experiment are our independent variable, which is volts, and then our dependent variable, which is resistance, as well as the current. And our control is the value of the resistor, which is 328.
These are our materials.
And first, we have a battery cradle. Battery fits in here.
Also known as a battery crib.
Next, we have our batteries. They're 1.5 voltages each.
Wow, careful.
Yeah, careful. Oh, okay, now follow me. Next, we have our multimeter, which measures amps.
Wow.
After that, we've got our little alligator teeth wires, which connect everything together.
Wow, I've heard those are also called alligator tails.
That's what I said. Wait, all right.
Crocodiles?
Nope, not crocodiles.
Alligators, Michelle.
Next, shut up, please. Thank you. And next, we have our resistor. This measures about 324. 8, excuse me. 328
Also known
ohms.
as resistor.
All right. Now, we also use a pencil, a calculator,
A lab notebook.
Thank you, I'm speaking. All right, those are our materials. This is called a multimeter, and we're measuring amps with it. Amps is the amount of voltage running through the batteries. So to do that, we're going to measure the voltages of the batteries. So each battery is 1.5 volts. So we've connected our red cord, which measures the amps, to the very beginning. And then our white cord will connect to the first battery with our alligator clip. And so then we'll have to multiply this number times 10 to the negative 3, because this is measured in milliamps and not regular amps. So the first one is 0.00432. And if we move the white cord to the next one, our measurement is 0.00858. And last, our measurement is, I'm going to change this, so it's 0.0131, and I multiplied all of those times 10 to the negative 3, and I will do this for 10 trials to the very end. We have to connect the white alligator clips to our resistor for our data to be accurate.
This is our data collected. This is the volts, which will be graphed on the y-axis, and then the current is measured in amps and will be graphed on the x-axis. And as the voltage increases, the current increases. During the experiment, the multimeter measured in milliamps, so that caused us to convert the current for the x-axis amps by multiplying them by 10 to the negative third.
Using the data we collected, I took the numbers and plugged it into the calculator on the table and used linear regression to get the line of best fit, which was Y, which is volts, equals 369.98 ohms times X, measured in amps, plus 0. And then using that, we graphed it. Here.
And from this, we could tell, from our data, we could tell that as voltage increases, or voltage is directly proportional to current. From our experiment, we concluded that the greater the voltage, the more the current flows. As resistance increases, less current flows for a given voltage.
Who is?
No, it's not ohm, it's ohm.
George Ohms was born on March 16, 1789 in Iriangen, Brandenburg Bayreuth. George Ohms died on July 6, 1854. His nationality was German, and he studied physics, obviously. And he was best known for Ohm's law, Ohm's phase law, and Ohm's acoustic law.
Using his own equipment that he created, Ohm found that there is a direct proportionality between the potential difference voltage applied across a conductor and the resultant, which is the current, which we did in our experiment. The relationship is known as Ohm's law.
Wow.
If you are wondering, Ohm came from a Protestant family. His father, Johann Wolfgang Ohm, was a locksmith, while his mother, Maria Elizabeth Beck, was the daughter of a tailor. Although his parents had not been formally educated, Ohm's father was a rather remarkable man who educated himself to a high level and was able to give his son an excellent education through his own teachings. Had Ohm's brother and sisters all survived, which they didn't, he would have been one of a large family, but it was common in those times for children to pass away.
Why does Ohms even matter?
Why does he even matter? Ohm wrote the galvanic circuit investigated mathematically, in which he gave his complete theory of electricity. In his work, he stated his law for electromotive force, acting between extremities of any part of a circuit, in which the product of strength of the current, and the resistance of the part of the current.
Ohms is also known for his acoustic law. This is sometimes called the acoustic law or simply Ohm's law, and it states that a musical sound is perceived by the ear as a set of number or constituent pure harmonic tones. It is well known to be not quite true.
For the experiment, I did the setup and recorded data and did the videotaping.
Woohoo! For the experiment, I also helped collect data, and I graphed the data, and I calculated to find the line of best fit and the slope.
I looked up and carried out the procedure, and I edited the video, and all three of us looked up bits about Ohm himself.